This is R.D. Sharma Solution, Class 12, Chapter 19. Exercise is 19.3. Indefinite integrals we are taking. Now this is 1 plus cos 4x divided by cot x minus tan x. 1 plus cos 4x or 1 minus cos 4x you already know. 1 plus cos 4x is 2 cos square, whatever is there, divided by 2. So it will be 2x. Cot x minus tan x, let us take it separately. Cot x is cos x by sin x, tan x is sin x by cos x. And then this will be cos square x. I'm taking the LCM. You can just cross multiply and then write it here and then multiply the denominator like this, sin x cos x. And please remember, cos square x minus sin square x is cos 2x. You can multiply 2 in the denominator. So the denominator will become sin 2x because 2 sin x cos x is sin 2x. So whatever is coming, let us write it here. 2 cos square 2x in the numerator. In the denominator you have this. This already I told you it will be sin 2x. And this sin 2x is going to go up. You'll just see. Cos square x minus sin square x is already cos 2x. So this is a predefined formula. We have already done that in our trigonometry classes. It will be cos square x minus sin square x is cos 2x. So this 2 cos square 2x, this goes up, cos 2x again goes up. This goes in the denominator. And this 2 sin x cos x, which was sin 2x, it goes into the numerator. So we have this one. So this 2 was already there if you remember. So we cancel this 2, 1 cos gets cancelled. We have cos 2x, sin 2x. So only cos 2x and sin 2x remains. That means we have to multiply numerator denominator by 2. So this becomes 2 sin 2x into cos 2x divided by 2. Now the numerator again will apply the same formula. We have applied 2 sin x cos x as sin 2x. So 2 sin 2x cos 2x is going to be sin 4x. 2 sin 2x cos 2x is sin 4x and divided by 2. So 1 by 2 here, and this goes sin 4x, and integration of sin 4x we have to do. So you already know that, but there is only one thing which you need to remember. Differentiation of 4x also has to be done, and it has to be divided in the denominator. That is, sin x integration is minus cos 4x. Integration of 4x is 4, so it has to be divided in the denominator. Okay. Now 2 is already there. Negative sign has come from sin 4x. So we have negative 1 by 8 cos 4x plus constant of integration. This is your final result. So this is the whole procedure stepwise which you have to follow in order to solve this question. This is an important question. Let me ascertain again. Integration of sin 4x you know, but all other things is just trigonometry, is just trigonometric identities. Next one is we have already done 1 by under root x plus a minus plus under root x plus b. So this is this kind of question only. So we will rationalize it. How are we going to rationalize it? Under root x plus 3 minus under root x plus 2. So we are going to multiply the numerator and denominator with the same thing which is in the denominator with the say complementary sign. If it is negative, we will put positive. If it is positive, we will put negative. So here we will place plus here. So when we multiply this, the whole scenario or the whole idea is to get the a squared minus b squared in the denominator. And that will also solve our purpose of removing the root, under root. So under this a is under root x plus 3, b is under root x plus 2. So a square minus b square, what do we get? We get x plus 3 here, we get x plus 2 here. So it would be negative x minus 2, x gets cancelled, 3 minus 2 is a 1. So we have this under root x plus 3, under root x plus 2, we'll do it with dx. So this is, same thing will go for both of these integrals. Under root x plus 2 is x plus 2 to the power half, and x under root x plus 3. So under root x plus 3 is also x plus 3 to the power half. So what do you get? X plus 3 to the power half, x plus 2 to the power half, and with dx. And this goes x plus 3 to the power half plus 1 divided by half plus 1. X plus 2 to the power half plus 1 divided by half plus 1. What is half plus 1? It's 3 by 2. Half plus 1 is simply 3 by 2. Here also x plus 2 to the power 3 by 2 divided by 3 by 2. Half plus 1 is 3 by 2 only with the constant of integration. So x plus 3 to the power 3 by 2. Here also x plus 2 to the power 3 by 2. This half plus 1 in the denominator will take them common, and this 3 by 2 goes up and it will become 2 by 3. So 2 by 3 you can take common. Inside you will get x plus 2 to the power 3 by 2 and x plus 3 to the power x. First one is x plus 3 to the power 3 by 2. Please remember. So this is what we have just done. Main idea is to rationalize the denominator. When we rationalize, other things are quite known to you. Now just assume that we are integrating tan square x. When we say tan square x, it's simply equal to sec square x minus 1. We'll apply it here. It will be integration of sec square 2x minus 3, and because x is actually 2x minus 3, which we are taking, minus 1 with dx. Separate these two terms, so sec square 2x minus 3 dx minus integration of dx. Sec square is what? We have a direct result. It's 10 2x minus 3, but we'll not stop here. We have to differentiate 2x minus 3, that will be equal to 2, and that needs to be divided. So just divide it by 2 here. What is integration of dx? It's simply x. So we have a constant of integration along with this. So this is your solution. So what you see here is a very straightforward solution. If you know the tan square x formula, this is quite easy, but remember to differentiate 2x minus 3 and divide the content before actually solving the result. Now I told you previously why we differentiate and put that content in the denominator. So this question is actually a hint, because in the later coming exercises it will be used immensely. 1 by cos square x is what? It's sec square x. You already know that. And what is 1 minus tan x? So 1 by cos square x we are going to take as sec square x. This 1 minus tan square x will take 1 minus tan x as what? As say a t or a p or a q. You will just see what benefits it's going to provide. 1 minus tan x, you can write it as t. So when you differentiate both the sides, let us differentiate both the sides. So we are saying d by dx of both the sides. So d by dx of 1 minus tan x is equal to dt by dx. And this 1 becomes 0, and this is sec square x, negative sec square x. And this is dt by dx. So dx goes on the left. So finally we got dt equals to minus sec square x dx. You can also say that negative dt is equal to sec square x dx. So now we integrate this whole. So numerator will become what? I told you already, 1 by cos square x is equal to sec square x. So sec square x dx, this goes here. Sec square x dx is already being found out by us. Denominator remains as 1 minus tan square x. This numerator we have already got from here. It's minus dt, negative dt. Just replace it like this. 1 minus tan x, we assumed it to be t, if you remember. 1 minus tan x was t. So it is t square. So you just have to integrate 1 by x square kind of thing. That is, here x is replaced by t, but the integration remains the same. So we have to integrate this as t raised minus 2 dt. So this is minus t minus 2 plus 1 divided by minus 2 plus 1 plus constant of integration. This will become minus t raised minus 1 divided by minus 1. This minus minus becomes plus. T raised minus 1 is when you take it in the denominator, so it will be simply 1 by t plus c. So t we have actually assumed it to be 1 minus tan x. So you have to actually replace final answer with 1 minus tan x in place of t. So this becomes 1 by 1 minus tan x, and constant of integration remains the same. So now you see why we put this t to simplify this question. Otherwise it will be very difficult to solve this kind of question. So this is how you're going to do it. Step by step solution is in front of you. If you're doing it by yourself, you can refer here. All these English like things, you have to write it by yourself. That will make your solution perfect. Okay, so we have completed 19.3. Thank you so much and have a good one.